Okay, this is the questions and answers in chapter 3, elements, compounds, and mixtures. Hopefully you've tried these questions. Please make sure that you study chapter by chapter and answer the questions before you check the video. So let's take a look at the answers and let's see whether your answers are correct or wrong. So define element. What was the definition of the element? Element is a substance made up of only one type of atoms. Please don't say one atom. It's not one atom. It's many atoms, but all of them are the same. So it is one type of atoms or identical atoms. Okay, what is meant by compound? Of course, you should know that compound is a substance made up of two or more elements chemically combined together in a fixed ratio. Chemically combined together in a fixed ratio. Explain what is meant by mixture. Mixture is two or more substances added together and can be separated easily. Don't say combined. They're not two or more substances combined. Once you say combined, then you're mixing up mixtures and compounds. So you don't say combined, you say added. Two or more substances added together and can be separated easily or can be separated by simple physical processes. Okay. Salt is soluble in water, sand is insoluble in water. This difference allows the mixture to be separated by the separators. So he gives you step 1, step 2, step 3, and he's saying in step 1, the mixture of salt and sand is placed in a what? What's that apparatus called? In a beaker containing which solvent? He said one of them is soluble in water and the other is insoluble in water. That means that the beaker should contain water. If he's talking about some other solvent, then we're using that other solvent. Okay? And stirred with a what? What do we use to stir the solution? Please don't say a stirrer. It's called a glass rod. The stirrer is not a choice anyway, but you're choosing from that box. But this is a common mistake that we say stir by a stirrer. Don't say stir by a stirrer. It's stirred with a glass rod. In step 2, the mixture from step 1 is poured through a what? So that's that apparatus labeled A. What is A? A is a funnel. Into a conical flask. In step 3, the liquid is transferred to a basin to allow the what to be removed. When you put it in a basin and you're heating it, you're allowing the water to be removed. Okay? What should be placed in A before the mixture from step 1 is poured through it? What is A? A was the funnel. So A was the funnel. What should I put in the funnel before I can pour the solution through it? I have to put a filter paper. What is the solid removed in step 2? So what is the solid that will remain in the filter paper? It's the sand that does not dissolve. Place crosses in 2 boxes to show the names of 2 processes used in this separation. So what are we talking about in this separation? We're not talking about chromatography. We're not talking about condensation. We're not talking about distillation. But yes, we have evaporation, that was step 3, and we have filtration, which was step 2. A student produces this chromatogram for 4 dyes A, B, C, D. So he has A, B, C, D, and he's comparing them to blue, red, and yellow. Which one of the dyes, A, B, C, or D, contains 3 colors? Remember, 3 colors means it gives 3 spots, and the spots are given horizontally along the same line as the spot that we originally put. So A gives 1 spot, B gives how many spots? 2. C gives 2 spots. D gives how many? 3. So it is D that has 3 colors. If it gives 3 spots, it has 3 colors. Which one of the dyes contains 1 color? That's the one that will give 1 spot. So the one that gave 1 spot is A. Each dye is made from 1 or more of the colors blue, red, and yellow. So he's saying that A, B, C, D, each of them must have either blue or red or yellow. So the student thinks that the results for one of his dyes is incorrect. Suggest which result is incorrect. So all of them should have blue or red or yellow. Which one does not have blue or red or yellow? That's B, because it's doesn't have any spot the same height as that of blue, red, or yellow. Okay. Rock salt is a mixture of salt and sand. Crystals of pure salt can be obtained from rock salt. So he's giving you this and you need to choose from the words. Grind the rock salt into a fine powder. Add the powder to hot water and stir to do what? To the salt. Stir to dissolve the salt. Filter the mixture. The salt what passes through the filter paper? The salt solution passes through the filter paper, leaving behind the sand. Boil the filtrate to evaporate some of the water. Leave the saturated solution to cool so that what of salt forms? Crystals of salt. Finally, do what to the cold mixture to separate the crystals from the remaining solution? Filter to separate crystals from the solution. Okay, this is a description of how the orange coloring can be extracted from rose petals. Rose petals, that means flowers, petals of flowers, and we're trying to get a color out of them. So he says crush the petals using a pestle and mortar. Add the crushed petals to some ethanol in a beaker. So he's trying to dissolve the color in ethanol. Heat to about 60 degrees centigrade and stir to produce an orange solution. Separate the orange solution from the petals. So just why ethanol is used instead of water? If he's using ethanol, that means that the color does not dissolve in ethanol. Dissolves in ethanol but does not dissolve in water. So the orange coloring dissolves in ethanol but not in water. That's why he's using ethanol. Ethanol is a flammable liquid. So just how it could be heated safely. Remember when we were talking about experimental techniques, we said if I am heating something that contains ethanol, ethanol is flammable, so I should do what? I should heat in a hot water bath. Put the test tube into a beaker containing water, and it's the beaker containing water that has been heated, not the test tube directly. So we say heat in a hot water bath. How could the orange solution be separated from the petals? Petals are flowers, pieces of something that's not soluble floating around in the solution. So I can separate it by filtration. The orange coloring is analyzed using chromatography and is found to consist of two different colors, red and yellow. So if something has two colors, that means it should give two spots. So he says complete the diagram. That means you need to give two spots, and the two spots are vertically along the same line as where the original spot was. So two on top of each other, something like that. A student wants to find out if the green coloring in grass is a mixture of dyes. So he uses a solvent to dissolve the green coloring from some grass. He then separates the solution of the green coloring from the remaining grass. Which of these methods is used to separate the solution of green coloring from the remaining grass? So you're trying to separate a solution from grass, which is something that's not soluble. So of course we use filtration. Okay. The student uses a dropping pipette to place a drop of the green solution onto a piece of chromatography paper and produces a chromatogram. The diagram shows his results. Add 3 more labels on the diagram to show where the solvent is. Where is the solvent? The solvent is down there in the beaker. Where is the chromatography paper? Of course, that's the chromatography paper. The original position of the spot, where did he originally put the spot? Below that line of 4 spots. It should be down there. Okay, explain how many different dyes are present. Well, how many spots do we have? We have 4. That means that we have 4 dyes. So we have 4 dyes because it has 4 spots. Okay, so far. The diagram below shows the results of the chromatography using the blue ink B and several pure dyes W, X, Y, and Z. So he's analyzing B, which is blue ink, and he's comparing them to W, X, Y, and Z. Which of the dyes were in the blue ink? Well, the dye that is in the blue ink will have a spot the same height as something in the blue ink, which is B. So B has 4 spots on top of each other. What spots are the same height? The one from X is the same height as that lower one in B. The one in W is the same as that middle one in B. And the one in Y is the same as that top one in B. So B must contain W, X, and Y, since it has spots the same height as W, X, and Y. How many dyes in the ink had been separated by this chromatography well? B. How many spots did it give? It gave 4. That means it has 4 dyes. Okay. Techniques used in separation of mixtures include crystallization, filtration, fractional distillation, simple distillation. Now, each letter may be used once, more than once, or not at all. So please remember that once you've used one of them, that doesn't mean that it cannot be used again. It could be used again. Okay, the first one, he's asking how to separate pure water from seawater. You should realize that seawater is a mixture of water and salt. So you have a mixture of water and salt, and you want what? You want the salt or you want the water? You want the water, then you should use simple distillation. Okay? Ethanol from a mixture of ethanol and water. Remember that ethanol is a liquid, water is a liquid, so this is a mixture of liquids. How do we separate a mixture of liquids? By fractional distillation. Calcium carbonate from a mixture of calcium carbonate and water. You may not be aware of this, but almost all carbonates are not soluble in water. So if I say I have a mixture of calcium carbonate and water, that means I just have water with some solid floating in it, because the calcium carbonate doesn't dissolve. So how do I get the calcium carbonate from that? By filtration. Now, copper sulfate 5 water solid from copper sulfate aqueous. That means I want a solid, which are crystals. That means I'm trying to get crystals from a solution. To get crystals from a solution, we use crystallization. Were you able to get these answers? You should be able to do that. And if not, then you understand why, what is right and what is wrong. Okay, pure PVA, doesn't matter what PVA is, it's a solid of some sort. Pure PVA melts at a temperature of 200 degrees centigrade. State how the melting point of the impure sample would be different. Remember that we said if I have a pure salt, it will melt at a certain temperature. So what if it's impure? If it's not pure, then the impure would have a lower melting point and it will melt over a range. Remember, this is melting point. Impurities make the melting point lower, but they make the boiling point higher. So this, we're talking about melting point, then it will make the melting point lower and it will melt over a range. It will not melt at a fixed temperature. Okay, a student investigates the pigments found in some vegetables and fruit. She obtains some colored vegetable and fruit extract from carrots, tomatoes, and sweet potatoes. So carrots, tomatoes, and sweet potatoes, she calls them V1, V2, V3. Can you see in the chromatogram? She places the spots along with spots of pigments, beta-carotene, chlorophyll, lycopene. So she calls them P1, P2, P3. So she has spots from the vegetables, V1, V2, V3, and spots from the dyes or the pigments, P1, P2, and P3. And the teacher provides a solvent containing volatile, flammable organic compound. So the solvent that she's using is volatile and flammable. What does volatile mean? Remember, volatile means evaporates easily. Flammable means catches fire easily. Okay, so the solvent is flammable and volatile. Now, can you see that he covered the tank with a lid, or she covered the tank with a lid? Can you see the lid? She's covering the tank with a lid. Now, explain why it's important, first of all, for the solvent level to be below the spots. So the solvent is below the spots. Can you see where the solvent is? The solvent is below the spots, and we said always you have to put the solvent so that it's below the starting line or below the spots. Why? To prevent the spots from dissolving in the solvent. I don't want the spots to dissolve in the solvent and fill the beaker with all the different colors. I want the solvent to go up the paper slowly and take the spots with it. State 2 potential problems that are prevented excuse me, by fitting the tank with a lid. So to avoid evaporation of the solvent, remember that we said the solvent is volatile and I don't want it to evaporate, that's why I'm covering it with a lid. And to avoid the risk of fire, since the solvent is flammable, so you don't want it to evaporate and catch fire somewhere. Okay, This is a copy of the diagram again of the chromatogram, and he's saying place a cross in 3 boxes to indicate your choice. So he's saying 3 of these statements are correct. Which ones are correct? So let's take them one by one. He's saying chlorophyll is not present in carrots, sweet potatoes, or tomatoes. Carrots, sweet potatoes, or tomatoes are V1, V2, V3. Okay? Now, chlorophyll is which one? Chlorophyll is P2. And he's saying chlorophyll is not present in V1, V2, V3. So I look at chlorophyll, P2. P2 has a spot that is not the same height as any of the other spots in V1, V2, V3. So this statement is actually correct, and he says place a cross in the correct box. Okay, what about B? B says beta-carotene is present in carrots, but not present in tomatoes. Which one is beta-carotene? Beta-carotene is P1. So we're looking at P1. And he's saying that P1 is present in carrots, which is V1, but not in tomatoes, which is V2. But that's not correct, because P1 has a spot the same height as a spot in V1 and a spot in V2. So that statement is not correct. So let's look at C. Both beta-carotene and lycopene are present in sweet potatoes. Which one is sweet potatoes? Sweet potatoes is V3. So we're looking at V3. And beta-carotene is P1. Well, lycopene is P3. So P1 and P3 are both present in V3. That is actually correct, because P1 has a spot the same height as 1 in V3, and P3 has a spot the same height as V3. So this statement is correct. Lycopene is present in tomatoes, but not present in carrots. Where is lycopene? Lycopene is P3. And he's saying it's present in tomatoes, which is V2. Yes, it's present in V2. So P3 has a spot the same height as V2. Okay. But not in carrots, and carrots is V1. But V1 also has a spot the same height as P3. So this statement is not correct. Statement E says both carrots and tomatoes contain pigment other than beta-carotene, chlorophyll, and lycopene. Beta-carotene, chlorophyll, and lycopene are P1, P2, P3. And he's saying that carrots and tomatoes, that is V1 and V2, have spots that are not the same as any of the P's. So V1 has a spot down there that's not the same as P1, P2, P3, and V2 has a spot in the middle somewhere that's not the same as P1, P2, P3. So this statement is correct. Are we okay? One of the pigments present in the vegetable extracts is not shown in the chromatogram. It appears as a very faint spot, 1.3 centimeters, and he's saying calculate the RF value. How do we calculate RF value? We said RF value is the distance traveled by the pigment divided by the distance traveled by the solvent. He says that the distance traveled by the pigment is 1.3. So I need to get the distance traveled by the solvent. And remember that the distance traveled by the solvent, I get a ruler and I measure the distance from the starting line to the solvent front. When I did that, it came out to be 6. So 1.3 divided by 6 is 0.22. So that means that my RF value is 0.22. Okay, do you understand how to get RF value? So just the reason why there is a spot on the starting line in the chromatogram for sweet potatoes. Sweet potatoes has a spot that did not go up at all. If you have a spot that did not go up at all, that means that the pigment does not dissolve in the solvent, or that specific dye, that color does not dissolve in the solvent. Okay, the diagram below shows the chromatography of 4 different food colorings. Which food coloring contains only one dye? So can you see A, B, C, D? Which one contains only one dye? One dye means one spot. So which one gives one spot? C. Which 3 food colorings have one dye in common? So I want 3 of them to have spots the same height. So which one has spots the same height? A, C, and D has the spot in the middle there, all the same height. Which food coloring contains the greatest number of dyes? Remember that when you look at A, it gives how many spots? A went up and gave 3 spots. B went up and gave how many? 4 spots. So that is the one that gives the more number of spots, so that's the one that has more number of dyes. Do we understand all of this? Okay, a liquid that dissolves solvents is called a what? A liquid that dissolves substances is called a solvent. Okay, this apparatus is used in a laboratory to separate a mixture of liquids with similar boiling points. So this is, remember, we call this what? This process is called fractional distillation. So use the words from the box to complete the passage, and always keep in mind that you may use each word once, more than once, or not at all, unless if he specifies that you can use it only once. The mixture of liquids is placed in the what? In the flask. During heating, part of the mixture boils and passes up the column. Remember, we call that the fractionating column. Water is used to cool the vapor in the condenser. Easy? Should be. Okay? Which of these changes of state occurs in the separation? So when we're doing distillation, which change of state is happening? Solid change into something? No. Liquid change into solid? No. Gas changing to liquid? Yes, because that's what happens in the condenser. The water vapor, gas, goes into the condenser and becomes a liquid. So that's my answer. Okay. The box shows some methods that can be used to separate mixtures. The table lists some separations. Complete the table by giving the best method for each separation. To obtain sand from a mixture of sand and water. Do you remember this? Sand is something that doesn't dissolve in water. I'm trying to separate it from water. This is filtration. To separate crude oil into its components, you should know, have an idea. If you don't, then you should know that crude oil is a liquid, a mixture of liquids. So several liquids, I'm trying to separate several liquids. We said by separating several liquids, I use fractional distillation. To obtain pure water from seawater, remember that we said seawater is a mixture of water and salt. So to get the water out of this, I use simple distillation. To obtain ethanol from a mixture of ethanol and water, again, ethanol and water are a mixture of liquids. To separate a mixture of liquids, I use fractional distillation. Okay? All good so far? Which of these methods is used to obtain water from a mixture containing salt and water? We just said water from a mixture of salt and water, that is simple distillation. State why the solvent level should not be above the baseline at the end of the experiment. Okay, so the solvent at the start of the experiment, the solvent should be below the baseline. We said that is to prevent the spots from dissolving in the solvent. Explain which dye present in one of the inks is also present in ink P. So we look at the chromatogram at the end. Which one, A, B, C, D, has something that is also present in P? Of course, it's B. And remember, he says explain which dye, and it has 2 marks. So you don't just say B and that's it. You have to explain why you choose B, and that is because it has the same height as a spot in P. It has a spot the same height as P. State why ink D does not move during the experiment. So ink D was something that stayed. Can you see that? D is a spot that stayed on the baseline. State why ink D does not move during the experiment. We said if a spot does not move up in the chromatogram, then it means it is insoluble in the solvent. Dyes have an RF value that can be calculated by distance moved by dye divided by distance moved by solvent. The distance moved by dye in the ink, I get a ruler and I measure from the baseline to the middle of the spot. When I did that, it came about 18 millimeter. He wants in millimeters. He already tells me that the distance moved by the solvent is 49 millimeters. So my RF value is the distance moved by the spot, which is 18, divided by the distance moved by the solvent. So 18 divided by 49 is 0.37. Okay. Investigation. He says, I have an orange drink. It may contain E110 or E129, which are artificial colors. Plan an investigation to determine the presence of these artificial colors in a sample of orange drink. So I give you an orange drink and I tell you, okay, find out, does it contain E110 or E129? Of course, to do that, you need to put a spot of the drink next to a spot of the E110 and the E129 on a baseline near the bottom of a rectangular chromatography paper. This is how you explain it. So put a spot of the orange drink next to a spot of E110 and E129 on a baseline near the bottom of a rectangular filter paper. Now put the paper in a beaker containing a very small amount of, specify the solvent. A very small amount of what? We said if we're talking about colorings, food colorings, or ink, then we need water. So these are food colorings. That means we have to put a very small amount of water. Allow the water to move up the paper. If the orange drink has spots the same height as the artificial colorings, they are present. You have to explain the experiment in detail, and you have to tell me how do I know whether my answer is correct or wrong. You don't have to tell me if it's correct or wrong, but you have to tell me how I determine what is correct and what is wrong. So if the drink contains one of these colorings, it should have a spot the same height as the coloring. Okay, and that's the end of the questions on elements, compounds, and mixtures.